r-Wesley presents Daly Free Energy Device. No battery, no power supply whatsoever. However, there is a need for the battery to start up. I'm not gonna show you that video. I'm gonna show only the preview of that video, and then I'm gonna try to mount from the 3 parts, one for video. But what I'm gonna go for is a deep analysis of the schematic. The schematic was posted on Russian site, and I found that interesting. That will help also to understand Aqua devices, as Aqua use the same microchip. So for those patient enough, I believe it's worth your time. The device started. Switching the device. I have a nanosecond impulse. You see the 2 diodes, and then you see small neon. The energy started. Flipping the switch, and we see the light bulb. Now he's disconnect the battery, taking with him, and go. We have a wave. Now, what we're gonna be dealing with at a certain point is that's it. This is the 0 of the amplitude, and this is the maximum. So what's gonna happen if we start to implement a high voltage, very narrow peaks that will start from 0 and go to approximately 3% before the very top of it. That would be to Lithuania experiment 50 Hz, and the peaks could be 1.2 MHz, but it could be much lower. It looks like that basic concept is something that makes a sense. Большое спасибо, ребята, с странника. Делаете очень хорошую работу. And then we're going to 2 videos on that side. Those are the videos of Daly. You could see those 2 parts. There are 3 parts. Only 2 of them exist on that side. We could go to another site, and that would be live internet site, and we could see all of the 3 parts in here. And I'm gonna try to put those parts together and make a video out of it. So remember, live internet, пожалуйста, заходите на live интернет. Спасибо большое. Умные русские ребята, русскоговорящие ребята, сделали схему. 1 impulse forming circuitry, 2nd impulse forming circuitry, and that magic coil. Magic coil is made out of 1 winding that is connected to the Grace bridge. 2nd coil that is made out of a coaxial cable RG58 and is shorted at the end. 3rd coil that is only with a capacitor, not connected anywhere. 4th winding that is connected to the impulse forming part. This is an inverter. So what it's doing is taking a 12 volts from the battery here and is changing it to, let's say, to 20 or 110 volts. Depends where in the world we are. So we have an AC here, we have a DC from the battery. So it could be car battery, any battery. When we close that switch, we will have 12 volts coming here and 12 volts coming here. As that switch is open, the only what we're gonna see after closing that switch is the LED light bulb, 220 volts, 30 watts, say, will light up. At the same time, that 12 volt is exactly the same 12 volts and exactly the same 12 volts here. So from that battery, the 12 volts should be connected here and should be connected to here. Now we have a power to those 2 blocks. Each one has a switch. Let's concentrate right now on the lower block. The lower block has a TL494 in it. There we go. The guy on that video is gonna say he is operating in nanosecond width. So each one is nanoseconds. So let's see what we have in here. I'm gonna try to speed up, guys. And now we have a comparator, oscillator, and then collector output voltage is 40 volts at 200 milliamps. Okay, in order for us to understand how the TL494 works, it works in many concepts used by a free energy community, guys, and it's good to understand how it works. Even for those who are not familiar with it, it's simple. And I'm gonna go in details to it for some who think they can make a change, because we cannot underestimate anyone. We're all fighting for a better future. So let's go to it. This is a chip. You have two transistors. There are two outputs. 11 and 10 is collector and emitter of the Q2, and we have 9 and 8. It's the emitter and collector of Q1. This particular schematic that I'm not gonna touch, it's not important. We have 8 not being used, 9 is being shorted to the ground exactly with emitter of the working output. So this duty cycle, we have a 50%. So, and this works in asynchronic mode, which means that we should have a flip-flop in here, but that flop is not being utilized. So we have a flip 0, flip 0, flip 0. So the junction is being open or closed. There might be some questions about terminology to use. When I say open, means no conducting. When I say junction is closed, means conducting. So now on the base of the transistor we have equal 0 or equal 1. We treat 0 as a 0 volts and 1 as the maximum amplitude of the square signal. Both of them, the width of them would be equal in time. Now this guy is giving us, this is another microchip, is giving us 5 volts from whatever the voltage is up to whatever 40 volts, 38 volts. It will always give us 5 volts. So we have 5 volts in here. The 5 volts goes to the power of this chip, but at the same time it goes to here, to that resistor, goes to the base here, and then goes down, and the transistor is open. So now we have let's say another scenario. It closes, it goes like that, like that, like that, like that, and that creates the closure of this one, and then eventually of the current flow like that. We may also see, if that junction is closed, that this transistor will be capacitively discharged, and it would go like that. Like that.
Q2 закрыт. Подается смещение через резистор R16 на базу транзистора VT2 и через резистор R19 на землю. Транзистор у нас в это время VT2 открыт. Через резистор R18 транзистор VT2 через диод VT1 заряжается емкость затвора транзистора VT1, и транзистор VT1 открывается. Когда открывается транзистор Q2, у нас наше смещение закорачивается на землю, и транзистор VT2 закрывается. В то время как открыт транзистор Q2, через него начинает разряжаться затворная емкость транзистора VT1 через резистор R17 и на затвор.
Okay, so one more time, closure, go like that, like that, and then we have a closed circuit.
Вот таким образом. Вот и весь цикл работы транзистора VT1.
That's the microchip. TL494. Let's see what we have in here. That's the Q1 that I was showing, that's the Q2, that's the collector emitter. Now we have a leg 13. We put 0 on leg 13, or we put 5 volt at leg 13. We either causing those two guys to work together or work flip-flop mode, which would be asynchronic mode. But for those Russian guys who wants to understand, I'm gonna include Russian as well. Now leg 12 is giving us the voltage for the chip. The reference would be 14, that would be the height of the peak regulation, and we have a ground wire. Now the dead time comparator, how much of the dead time do we have, is on leg number 4. And then we have two input amplifiers which we can play with, and then we have an equal response on this side if you want to. So let me go to the Russian explanation. Beautiful one. Спасибо большое. Очень хороший, мне очень нравится.
Неинвертируемый вход первого усилителя ошибки, вторая нога, инвертируемый вход первого усилителя ошибки.
And I forgot to say, we have an oscillator in here and a leg 6 and 5. That's how we can regulate the frequency of oscillation.
16-я нога, неинвертируемый вход второго усилителя ошибки, 15-я нога, инвертируемый ход второго усилителя ошибки.
So the voltage here on 16, then we have no inversion, and 15 we have an inversion.
Третья нога — это у нас обратная связь. 14-я нога — это опорное напряжение плюс 5 вольт. 12-я нога — это они микросхемы. 7-я нога — это у нас общий провод, земля. Схема может работать как в однотактном, так и в двухтактном режиме. Если на 13-й ноге у нас 0 вольт, то схема работает в однотактном режиме. Если на 13-й ноге плюс 5 вольт, то схема работает в двухтактном режиме. Если схема работает в однотактном режиме, то транзисторы Q1 и Q2 работают синхронно. Если у нас схема работает в двухтактном режиме, то транзисторы Q1 и Q2 работают в противофазе. Задержка, которая определяется у нас 4-й ногой.
Flip-flop, and number 4.
Схема.
Number 4 is giving a time of the interval. So this guy is giving us at leg number 10 and leg number 9 impulse. Those goes to the base on the transistor, and then collector base on another transistor here, and the base. Then is sort of terminated with a transformer, but the transformer has two windings, and one of them, the middle top, is going to 12 volts, and that's the 12 volts that comes from the battery at first as an impulse. So let's say we have that impulse, we get the 12 volts, we have that K1 switch close, and then it goes here. Now from here we have one way here or one way this way, but nothing is going to happen because this is. So is this junction, collector emitter junction here, and this junction here. So what we need is if we have a voltage on the base, then we close it. And we have a voltage on the base, then we close it. So this guy is giving us the signal. Flip-flop. Now what we're having in here is flip-flop, flip-flop. Now what we have in here is flip-flop, flip-flop from the other side. So now we see that this winding is connected to the Gratz bridge, which is a rectifier, and goes to 150 volts. So this winding has to give us at least 150 volts. So now we know at least what this should represent. So where this 150 volt goes, well, the 150 volt goes in here to this part. One more time. Battery, switch, starting the device. 12 volts down, 12 volts up. 220 volts AC here. This thing will have a signal. 12 volts goes down, goes to the switch here, goes in here, and start the device working. So we disconnect 12 volt battery here. We disconnected voltage, but we have the impulses in here, and there is a time difference between those impulses and that resonance circuit in here. 12 volt no longer being powered from that battery. Receive the AC on this side, a number of capacitors in here for the temporary storage. Then through that switch to that Gratz bridge, back impulse here. We didn't go yet to this part. So this part we have, let's assume that we have the 12 volt battery. That 150 goes in here and comes here. And we're dealing with 74HC HCT00 or the Russian chip, which would be KP1554 LAZ, and that would be, this is the guy. It's pretty fast, it's 70 nanoseconds, and it has high speed access time. That was one of the things with all of this Capenazet stuff and all of the KUA stuff that might matter. Fast impulse, fast rising and falling edge. Now you have a block diagram of it. We have two of them, one in here and one in here, and then we see how the impulses goes. Power regulator. So it does is you give it any voltage, say 7.5 to 35 volts. In results, you get 5 volts. That's what you need. So you have a Zener diode in here, and part of the P filter. 100 nanofarads for the ripples. Rejection, only 3 legs. So you have two of them, one in here and one in here. Because we have a 12 volts from that battery to this point, and from that battery to this point for a moment only. We have a 12 volts come here, 5 volts coming back, regulated, going to this guy, and going to this guy. So I have leg number 14, like that, like that, like that, like that, like that. And the end of this part is a pulse width modulation. So it's establishing the width of an impulse. Signal going like that, and from here to this guy. And if you recall, RG58 is our coaxial cable, and we already have on the collector of that transistor very nice peaks, impulses that I was talking about on this video. I didn't show those peaks, but they look like a zigzag in here. And then you have a two Schottky diodes, pretty powerful one, KP203, two of them. When 150 volts come in here, we have a neon that will give us indication of the presence of that 150 volts. So that would allow us to adjust the frequency if you want to, because we would see those impulses. Then it goes through the drossel, which is the choke. That thing will stop any AC coming. On the other side of the transformer, we have this Gaussian shape of the peak. What is that diode for? Well, if we have a standing wave that is coming back and this acts as a transmitter, because that standing wave is hitting back, is accumulating on this winding and eventually hitting back to the collector. So it should overheat the transistor, but it's not doing it because of the diode. The diode is simply shorting it when it comes back. The best way to explain that is as if we have a sine wave. This is the negative from 0 to minus is negative part, and from 0 to plus is positive. So the diode is only giving us conductance one way. Let's come back to this one. Now we need to concentrate on this part and the role of the coaxial cable. The RG58AU is 50 ohm. So if we say that we have a matching impedance of this part of 50 ohm, then the signal should go through that coaxial cable, and eventually if we connect in here 50 ohm resistor, it would dissipate on that resistor. We would have a perfect match of impedance. Let's say we have that coaxial cable open or short. Guess what? This guy would never see it short. It would see it open as if it didn't exist. So my understanding is whether you short it or you're not shorting it, at resonance you will still have mismatch of impedance at the end of it. That energy could not go further, it goes back and hit that circuitry back. So we have another diode here, and then we have an impulse actually dissipating through the diode. So it's good if that diode has a heatsink on it. But imagine that we have a series of impulses coming in here that are modulating that signal with a very nice peaks. Let me take a break. I got tired of doing that video. It's pretty much time consuming. So I decided to split it on a few parts. Definitely you guys need to see the video in all of the 3 pieces that I found, put together and translated. So then you will have a full picture of what I'm relating to, what I'm translating, and where are we going to with that. It's so far not that difficult. Still thinking on that, how to probably translate a schematic and the concept of creating free energy. We've got to understand free energy must come from somewhere and be converted to usable form of the energy. One of the major factors contributing to energy extraction is ground wire. So some of us say, hey, we don't have any wire, but we need to have a ground wire. So one of the concepts behind that is that we have electrostatic pump, and that electrostatic point has a certain time delay. And of course a huge capacitive reactance. So when there is a need for electron to be sucked from the ground, there is an inertia, and the next impulse is requesting the action, but in the meantime inductively coupled load circuitry with light bulbs is dissipating the power. It's kind of hard to explain exactly what's going on. If it was that easy, we would have already Tesla and other guys doing that. Well, we don't have it. And not because it doesn't exist, we don't have it because there is a greed. Everybody who gets something deletes the video, shut up, try to deal with somebody, make some money, including Akua, Tariel Capenadze. How many guys did we have? Newman, Stanley Mayer, that guy. So many of dead guys. And yet, anybody who makes it, he wants to patent. Nobody's gonna give you the patent. They not allow you to corrupt the wealth of 1%, and we are only 99. Think, guys. I'm working on Coleman. That's what I'm doing, is just because I want to contribute. Anyhow, powers of the world, energy powers, screw you all. Have a good one. This is Wesley, and it's Wesley News.